listen-only mode.
Welcome to WESTPAK's webinar on ASTM versus ISTA package testing. I'm Greg Swinghammer. I'll be your moderator and webinar organizer today. Before we get started, let's take a moment to ensure that everyone is ready and familiar with their webinar control panel. First, you should have a control panel on the right side of your screen. You may minimize this panel by clicking on the orange arrow button in the upper left-hand corner. You may expand the panel by clicking on the same button. Secondly, you have the ability to submit questions using the chat pane located near the bottom of the control panel. We will be answering a few questions during the webinar. However, if we are unable to address your question during the webinar, our presenter will follow up with you via email afterwards. Today's webinar and video slide deck should be available on WESTPAK's website tomorrow. With that, let's get started. Today's presenter is Tress Wood, a test engineer here at WESTPAK, who also serves on the ISTA 3 Series Technical Service Group. Tress, take it away.
Thanks, Greg. To start off, here are some definitions that some of our audience may or may not be aware of. ASTM stands for the organization formerly known as the American Society for Testing of Materials. They publish many different physical testing standards, not just for packaging tests. Their acronym is now their preferred method of address. The International Safe Transit Association, ISTA, focuses on physical testing of packages and package systems. ISTA recently partnered with the American National Standards Institute to open ISTA process to a wider consensus group. And for those of you that are not familiar, ANSI is the member in the United States of ISO, the International Standards Organization. We'll compare ASTM tests in this presentation with the most commonly requested ISTA tests. We'll work from simpler tests to more complex ones. Then toward the end, we'll share some stories of how some of our larger clients are dealing with the differences in their tests. Today, we're focusing on single parcel shipments. Many of the 3 Series ISTA tests for pallet loads are currently under revision. Anyway, the vast majority of the tests that we do focus on single parcels and fewer on those pallet load quantities. Of the single parcel tests, the overwhelming majority use either ASTM D4169 or an ISTA test from the 2 or 3 series. Your transport environment and specific package system should drive what test you choose, regardless of the cost. We'll start by comparing ASTM and ISTA packaging tests in general. Then we'll get a little more specific, focusing on some common package testing scenarios. Then we'll share some information to help you make the best choices when you begin to test. And we'll share some stories of how an informed test selection can help you make your best decision. Starting at the beginning, ISTA 1 Series tests are among the oldest package integrity tests that are still in use. ISTA refers to these tests as non-simulation tests, in a tacit acknowledgement that these tests don't reflect an updated understanding of how complex the transport environment is. Parts of ASTM D4169 and D7386 are similar to parts of ISTA 1 Series tests, but there is no easy, direct, one-to-one comparison between them. The thoughtful use of ASTM D4169 distribution cycle number 2 can replicate almost any ISTA test series, especially the ISTA 1 series. The ISTA 2 series tests were originally envisioned as improvements to and expansions of the ISTA 1 series tests. These tests are referred to by ISTA as partial simulation tests because they are more comprehensive than ISTA 1 series, and they also include at least one ISTA 3 series test input to increase correlation with real-world results. As with the ISTA 1 series, there is no direct correlation between ASTM testing and the ISTA 2 series tests. But once again, ASTM 4169 distribution cycle 2 can be configured to be somewhat similar to ISTA 2 series tests but there will be differences in vibration spectra and in other test inputs as well. Those differences, especially dealing with compression and drop testing, are a major part of what we'll be talking about a little later today. Moving on, the ISTA 3A test was developed in conjunction with UPS, the United Parcel Service, as a pre-shipment certification test method. This test was specifically designed for packages in the small parcel shipping environment, which is UPS's specialty. If you file a damage claim with UPS, one of the first questions you may be asked regards whether the package system has ever been tested and to what standard. In response, ASTM developed the D7386 test method, drawn in large part from inputs under ISTA 3A and adding some additional test inputs. Both tests will yield similar results. And as a warning, both of these tests have top-load vibration that can damage or destroy many boxes under a 275-pound burst or 44 edge crush rating. So, medical device manufacturers often use ISTA 2A as a less expensive alternative to ASTM D4169 testing because on average, it's about half the cost. Half price sounds nice, right? But before you decide, remember that the devil is in the details. Let's take a box, 22 inches by 20 inches by 18 inches, weighing 16 pounds. These are just numbers that I randomly picked. The ISTA 2A standard expects this box to withstand 359 pounds of compression. ASTM D4169, the same box must survive 1,146 pounds at the lowest allowable testing level, assurance level 3. Double that value to over 2,200 pounds if you test to assurance level 1, which is considered to be the worst case. Since the ASTM 4169 formula yields a bare minimum compression value that can be more than 3 times that of ISTA 2A on boxes above 2 cubic feet and 30 pounds in weight, it's no wonder that many medical device clients cut their assurance level back to assurance level 3. My best advice, the advice that I give to my customers, is run the numbers before you decide on a test method. The only user adjustable variable in either formula, ISTA 2A or ASTM 4169, is the safety factor. And any deviation from the published normal values in these standards is going to require extra justification to be written. So therefore there is a practical limit to how much you can reduce the compression load. But here's a bit of that detailed deviltry I was talking about earlier. ISTA drop or impact testing uses drop heights determined by weight. Now, the same thing happens under ASTM D4169, but those heights can be adjusted by use of the assurance level changes. The heights that you're looking at on the screen for the ASTM drops use assurance level 1, which is considered to be the worst case, but it is also the most commonly chosen test scenario. ASTM allows their drop heights to be reduced further if the assurance levels other than assurance level 1 are chosen, but that makes the drop test differences even more pronounced. Another point to remember is that ASTM D4169 does not use a dynamic top load in distribution cycle 9 or 13. Distribution cycle 13 is one of the most commonly used ASTM 4169 test plans. So ASTM 4169, other than 3 distribution cycles, number 2, number 9, and number 13. ASTM 7386 and ISTA 3A require a top load during vibration testing. And since 7386 kind of grew out of ISTA 3A, the top load requirements are similar. Feedback that we've received from medical device manufacturers, not just in our test lab, but in other test labs, has been pretty consistent that the damage that's inflicted by dynamic top loading during package vibration testing, that type of damage is not often seen by them. So these next slides are a summary of the differences and the similarities between the tests for ISTA and ASTM. So to sum it up, for ISTA Series 1, these tests are among the oldest package test methods that are still in use. And they are very useful as a quick, low-cost comparison method between package designs. If this is the only method available, some will write a test protocol that reduces the vibration time because the vibration is very severe in ISTA 1A. Going on, ISTA 2A is an often used transit test for medical devices. Lower cost and less test lab time are attractive reasons to use the test. The test is accepted by the FDA as a grandfathered in test under ISO 11607. And the compression testing is usually less challenging than ASTM 4169. However, some results have given some of my customers some concern because boxes weighing under 21 pounds can drop 10 times from a 38-inch drop height. And some customers have told me that they think the high drops could be a problem for their sterile barrier packaging. ASTM 4169 is also a very commonly used transit test, especially for medical devices. It does cost more to run, but you do have a high level of confidence that you're getting a realistic test. It's a recommended test by the FDA, appearing on their consensus standards list. It can be altered to suit your specific transport environment up to a certain point. Many of my customers cut back their transportation top load test to the lowest assurance level 3, but passing it for some is still a challenge. But for both of these test procedures, the lab-induced damage is usually fairly similar to what is seen in the real world. And here's a summary of the differences between ISTA 2A and ASTM D4169. This slide uses our example box from the previous slide, 22 inches by 20 inches by 18 inches weighing 16 pounds, which yields a 4.5 cubic foot box. Note the differences in drop height and compression between the two standards. Although the ASTM vibration lasts longer, it is still considered less intense than the ISTA vibration due to the varying intensity levels and the waveform that ISTA uses for their new truck profile. Moving on to summarizing ISTA 3A, it is a frequently used transit test. It's just not used frequently by most medical device manufacturers. It was designed in coordination with UPS to mirror the single parcel environment. The top load requirement in ISTA 3A works very well for UPS shipments, but the medical device transportation environment is quite different. ASTM 7386 is also an often used transit test. Again, it's just not often used by medical device manufacturers. ISTA 3A and ASTM 7386 are recognized by the FDA as consensus standards, just like ASTM 4169. Some of the pros of ISTA testing: they tend to be priced lower, older equipment can run the tests, the box orientation is specified very specifically in most procedures, which can be a real help to you when you're doing inspections because you can actually trace the damage from the outer part of the box to the inner part of the box, even if it's hard to tell on the outer part of the box where the test input happened. The ISTA 2A compression values are usually less severe than those required by ASTM D4169. In the ASTM testing, some of the cons with it as compared to the pros of ISTA testing: usually higher priced, usually takes longer, and definitely needs more complex equipment. It can be a little bit more difficult to work on the correlation between what happened to the outside of the package versus what you find on the inside when you inspect. And as we've stated before, many of our medical device folks will not use tests that specify dynamic top load during vibration because they see damage there that they don't see out in the real world. Now, some of the cons of ISTA testing as compared to some of the pros of ISTA testing. ISTA 2A has higher drop heights, and that is a problem for some of our medical device folks, as we'll discuss in a few moments. The vibration sequence is an older specification, and it usually gives a somewhat higher average test intensity, but for a shorter time. The altitude testing now is only spelled out in ISTA 3A and is only designed to run during a vibration sequence. But with ASTM D4169, altitude testing is independently spelled out. The intensity for many other ASTM test inputs, such as drops, compression, or vibration, can be reduced by reducing the assurance level. The new truck vibration spectrum under ASTM 4169 is based on real-world data. And for information about that, you can see our other webinar that we did recently regarding the new vibration spectra with 4169. ASTM 4169 and 7386 are, as we've said, listed in the FDA list of consensus standards, which can make getting your approval a little bit easier. The ISTA 3 series test is also a consensus standard now. The other 1 series and 2 series tests are grandfathered in. And here's a quick reference regarding the difference between ISO 11607 listed test standards, which we otherwise referred to as grandfathered in, and those listed on the FDA website that we cited at the beginning. ISTA's new partnership with ANSI should soon see those remaining ISTA standards listed as consensus standards on the FDA website. So, solution cases. Study number 1, we had a large medical device manufacturer having difficulty with their sterile barrier integrity. As you can see, that pen should not be where it is in that pouch. You can see the matte finish below the point where the seal has been completely ruptured. Pouch seals were creeping to failure because of the impact of the device card with the inner seal boundary at these high drop heights. After consultation with some WESTPAK engineers, this manufacturer chose to test instead with ASTM 4169. Those lower drop heights, we feel, helped them have no further issues with their breaches in their sterile barrier. Another study, we had a consumer goods company that kept having compression failures on their boxes. When they switched over to the ISTA testing, the boxes started passing the tests and their test cost was reduced. So that brings me to the end of the active presentation of the webinar. And so it's time for questions. So Greg, are there any questions from our audience?
Hi Trace, yes we do have several questions here, and thanks everybody for sending them in, and if you want to send in more questions, please feel free to do so, and we'll try and get them all answered as we can. Oop, hang on, too many slides. There we go. First question is, it looks like the FDA website lists ISTA 3A 2008, 3B 2012, and 3E 2009. But this person's wondering why they don't recognize ISTA 2A.
Okay, that's a very fair question. Can you hear me okay?
Yeah, I can hear you great, Chris. Thanks.
Okay, awesome. The ISTA 2A, we expect, will probably be recognized as soon as the ISTA Technical Series Group for ISTA 2 series testing finishes the periodic review of the standard, because as you'll notice, the ISTA 3 series, several of those procedures are already out on the FDA approval website, and we expect that the same thing will probably happen as soon as ISTA 2A gets through that TSG process.
Cool. Thanks, Trace. Next question is, could we run testing through ASTM D4169 but substitute the compression test for ISTA and random vibration, basically mixing them, or do we have to stick with either ISTA or ASTM D4169?
Yeah, another good question. Basically, you are able to mix and match elements of testing as long as you are comfortable writing the justification that you'll be passing through your audit staff and everything. And we do have customers that do mix elements from different tests into their approval series. In fact, we have one large customer that does the drops from one particular variety of ISTA testing in the middle of their ASTM tests. And they're able to do that because they've written the justification. So yes, if you can make the case that changing the test sequence or the test inputs more closely matches your distribution environment, then you would be able to mix and match.
Cool. Thanks, Trace. Next question. Can you elaborate on what is meant by grandfathered in for ISTA 1A and ISTA 2A?
Sure. The grandfathered in basically is the phrase that we're using to describe the standards that are authorized for use by ISO 11607. The FDA has agreed to accept these standards because they are in an ISO standard. They're not appearing yet on the list of the consensus standards that we have posted the link for on our presentation. But again, we expect that those standards will eventually show up on that list as the partnership between ISTA and ANSI progresses down the road, and those standards are reviewed by the respective TSGs.
Cool. Great. Thanks, Trace. Looking at most of the information is focused on medical device industries. What about other industries?
Well, basically, I like the quote that we had in our previous webinar where Bill Kipp states that if you're seeing results from your testing that are not matching what's going on in the real world, that you should probably look at what you're doing as far as testing. Because the idea behind all these package and product tests is to match what you're getting in the real world. And so my best suggestion with this is know your distribution cycle. And if you're seeing damage that's not being reflected by your testing, then you should speak with your test services provider and you should get that resolved, because ideally you bring a test into your test service provider, you have the test done, and it should be, if the testing is properly selected, and properly conducted, it should be very predictive of what you're going to see when you get your product out there in the real world. So some of the same principles do apply. It just, again, you have to know your distribution cycle in order to talk with your test services provider to make these kind of good choices.
Cool. Next question, it seems that the standards are for small packages. What does ISTA or ASTM call out for large crates weighing over 4,000 pounds?
Okay, we did not really look at the crate testing as part of this presentation. Both ISTA and ASTM do have procedures that are somewhat similar to go through. In fact, the ISTA 3 series was just revised before they appeared on the FDA website, and you have several of those test inputs have been harmonized to more closely resemble what ASTM is doing. And so I can say with a fair amount of confidence that you have fair similarity now between a lot of your ISTA crate testing and the testing that's designed to be done with the ASTM procedure. One of the big differences, of course, being your vibration spectrum.
Great. Next question. There are a lot of other ISTA standards out there. You barely mentioned them. Why?
Again, basically, we only have so much time to present our webinars every few months, and the scope of this webinar was a little bit daunting simply with the amount of test standards that we did discuss and we did cover. And if we'd brought the rest of them in, we'd probably be here for another hour at least. But a lot of material to cover, and possibly some material for a future webinar where we can break down your choices with palletized or crate testing.
Great. Thanks, Tris. Next question is, why would you use ISTA 1A or 2A if you were looking for a full simulation or handling, shipping, and storage?
Well, actually, I don't think you really would, because in the material we state that it's a good quick test to be able to compare different packages, but I certainly would not recommend the ISTA 1 series or the ISTA 2 series for a full simulation by itself. But again, you know, the ISTA themselves refers to these 1 series as a non-simulation test, and the ISTA 2 series as a partial simulation test. And so it's recognized by the group that governs these procedures that they're not designed for a full simulation of handling, shipping, and storage. But again, the ISTA 2 series, being recognized under ISO 11607, is allowed to be used by our medical device folks when they are looking at qualifying their products for market.
Thanks, Trace. Back to the creative one. I should have asked this one after that, but we'll loop back to this one. Since your slides specified ISTA 2A, how about ISTA 2B compared to ASTM D4169? Similar with ISTA 2A, is it similar to ISTA 2A compared to ASTM D4169?
Well, that's a really good question. And just quickly looking through the standard, you have the same compression formula on the 2B standard as you have on the 2A. And so your compression values at the very least would be somewhat similar. Again, this is going to vary as far as your package height, your package weight, the different variables in that formula. And again, because of the amount of time, we really weren't looking at the heavier packages for ISTA 2B. I believe the cutoff is 150 pound, if I'm remembering correctly. And so we really were looking more at the single parcel medical device type of environment than we were the palletized or large parcel environment. Just again, the scope of the webinar, we felt like we kind of had to limit it some way.
Cool, great, thanks Trace. Next question. I don't think you mentioned the use of Schedule B warehouse stacking formula in ASTM D469. Why?
Well, there's a couple of reasons for that. The main reason that I didn't bring it up is because I have had that particular test schedule requested one time in 3 years. So it's not very commonly requested. Another reason to not really discuss that is that it is considered to be a standalone test input if you look at the test schedules in ASTM 4169. It basically is designed in the majority of cases to be added on to another test sequence. So in other words, if you wanted your packaging to see the warehouse compression test, you can certainly do that. But without the rest of the elements in one of the particular test schedules that they have listed, it's not going to have a lot of meaning for you. And most of those other test schedules that you add the warehouse stacking to will involve stack vibration, which again we've discussed in the webinar is very damaging to a lot of packages.
Thanks, Trace. And just to add on to that, in my 16 years of doing testing, I think I've only ran the warehouse stacking 3 or 4 times, so it's not a very popular add-on for that.
Exactly, exactly.
Our next question, say products are shipped to end users, then unused products are then sent back to manufacturers, then redistributed. How do we account for this possibility of very long distribution situations?
Well, basically, my recommendation for that would be to talk to your test services provider and consider the use of, I'm getting the correct DC here so I don't misspeak. I would consider the use of distribution cycle 2 because it basically allows you to pick your test inputs from any of the different ASTM schedules. And so if you have a specific distribution cycle that you know your product's going to be facing, then talk to your test services provider and talk to them about DC2 and the specially defined distribution system that you can design there. And I know our engineering services folks here at WESTPAK would be more than happy to have that conversation with you.
Cool. And to add on to that one also, we had a customer a few years ago that had that very same situation, and they ran it through distribution cycle 13 several times, checking the sterility between each distribution cycle. So they didn't re-sterilize, but they ran it through the D4169 multiple times just to see how many times they could get through before they had failures.
That's really a pretty good idea, actually, and I guess save you having to design your own.
Next question, my company uses ASTM D7386 and we have no issues like those you described in the presentation. We think the test reflects our environment very well. Care to comment?
Absolutely. This is great. This is the kind of thing that we look for in the test services environment. We want to make sure that what's happening in your lab is the same thing that's happening to your product out on the street. And so I'm not going to be the one to tell you that this is not correct, because if you're getting good matched results, then that's absolutely what you should be doing. And not every environment is the same, and that's why for the majority of our customers, the advice that I've given in the webinar today would apply. But there's always going to be a situation where the distribution cycle is different for a particular company, and so the testing that is picked may also need to be different. And I'm really glad to hear that this is working out for you, and I wish you a lot of continued success.
Great. Thanks, Trace. Where can they purchase the ISTA and ASTM standards is a question here.
Okay, for ASTM, my recommendation is to go direct to astm.org. There are some other third-party distribution facilities. I have not done comparative pricing. You may or may not see any sort of a price break by going to ASTM, but I also know that they send me a lot less spam than the other document distribution sites. As far as ISTA, the place to go for those standards is ISTA.org, and they would be able to provide you the latest copy of individual standards for purchase, or the entire resource book would be available, I believe, through their bookstore. But ASTM.org or ISTA.org should be able to help you with those.
Cool. Thanks, Trace. Next question, if your product will not see any other products stacked on it, can you specify the top load weight?
We do have customers that do specify custom top load weights, and as long as you are able to write the justification that passes your auditors that says this is what my product sees and we don't have any issues, then yes, talk to your test services provider and get a customized protocol put together. Otherwise, some of our customers are recommending, they're asking us, excuse me, not recommending, they're requesting that we test for compression to assurance level 3 when doing the ASTM testing. But again, not every customer asks that, and some customers are perfectly content with testing to the full capacity of our compression machine, as it were.
Great, thanks, Trace. Next question, what are some examples of when using the ISTA, when would you use the ISTA 1 series as the most appropriate standard? Is there ever an appropriate use for it to use for a complete distribution cycle testing?
My personal experience with the distribution environments, and this is dealing with medical device, this is dealing with food, both wholesale and retail, working with food manufacturers and food distribution centers. You're probably not going to see a lot of use for ISTA 1 as a classical distribution simulation test, basically because the technology has progressed as far as vibration, and we now know a lot more about what vibration is actually coming up through those vehicles into our product than we did when the ISTA standard 1A was developed. However, I did have a food client that used ISTA 1A as again, a quick reference to determine whether their product was survivable. And this is not just in the distribution environment. This was in their internal plant environment and in their handling environment inside before this stuff ever got shipped. And so they set up that if their product could pass a limited ISTA 1A, then it would progress on to further development. But this food company had a lot of very delicate things they were trying to do with their products, and so that's why they used a rather severe test. But again, this was not for distribution. This was basically for the use that we spoke of in the webinar, where you have the necessity of comparing apples and apples in a particular situation. And while ISTA 1A was a very good distribution test when it was the only kid on the block, the technology has, I think, moved on, and I think even ISTA recognizes that now by the way they classify the tests.
Great. We have several questions around conditioning. So I'm going to kind of use this as a general conditioning type question. Are there conditions or conditioning profiles that you would recommend using for either ISTA or ASTM testing, or are there required conditionings for those tests?
I can tell you what the majority of our customers do, and I think they get pretty good success out of this. And again, this is going to depend on your specific product. It's going to depend on what you foresee your product might face when you send it out into the real world. Many of our customers will go with a cold cycle. Those temperatures anywhere from 18 to 30 degrees below 0 Celsius. Then they will step from that into a hot, wet cycle, the tropical cycle, and I think that both ASTM and ISTA define that as between 38 and 40 degrees Celsius and 85 to 95% relative humidity. And then just to add insult to injury, then they'll do a hot, dry sequence of, say, 60-15, and they will do the soaks in these temperatures depending on what they foresee their product's going to face out in the real world. And again, there's many of these possible cycles to pick from in the books, but those are 3 of the most common scenarios that we see.
Great, thanks, Trace. Next question. What about your experience with ISTA and ASTM? What do you see your customers testing more often under?
That's a good question. If you add everything together, I think you're probably getting a few more of my current customers that are testing to ASTM than are testing to ISTA. And would I want to come down and say it's absolutely 50-50 or 60-40? No, but it's vaguely in that range with a few more ASTM tests perhaps than the ISTA tests. But that's not to say that one is replacing the other in the market by any stretch of the imagination. It's we just basically have a lot of pressures that different manufacturers face when they're trying to get a product to market, and they take a lot of different paths. They talk to a lot of different people, and the choices are made based on their observation of their distribution cycle, what their test provider is helping them with. Hopefully they're getting the kind of help that we can provide here, and then they make the choice. What are they going to have to do to get this package past the reporting body, the auditors that they're going to be looking at? And so that's basically where I see people picking, and I don't really see a preference one over the other. I just that's where the balance seems to be right now.
Thanks, Trace. Next question. We did that one. Do you know if there is any effort into consolidating both ISTA and ASTM into ISO standards?
I'm not aware of it. I wouldn't be surprised if it might be happening on a higher level. As of right now, I haven't heard really anything. I do know that the 2 organizations are tending to do a bit of mirroring of each other, where we'll have something will come out under one standards body, and then you'll see something similar come out with the other standards body. So perhaps a friendly rivalry, perhaps the first steps toward a merger, but nothing official has come down that I've heard of.
Great, thanks, Trace. Let's see, the next question. Hang on just a second. Are there any companies that use their own standards?
We do have companies that do write their own test protocols. They will normally pick elements that exist in an existing ASTM or ISTA test. However, that's not to say that you can't pick your own. And again, buyer beware. If you pick your own, you have to have your ducks in a row so that when your documentation is looked at, that the auditor is satisfied that what you're doing to test your product is predictive of what that product may see as you send it out into the transport environment. And so, it's, again, a lot of variation there. We do see people do it. We see people that mix and match, and then we see people that just say, give me a straight ASTM or ISTA test right down the line. And again, it's all in the environment you find yourself in.
Great, thanks Trace. Next question, can WESTPAK help me identifying the appropriate test to perform, whether it be ASTM or ISTA, or a mix of them?
Oh, absolutely. We have our engineering services folks have years of experience in both performing and selecting the tests that our customers need to help them get their product to market in the minimum amount of time, the maximum amount of efficiency. And so we'd be more than happy to help with that.
Cool. Next question. If a full pallet of products are shipped overseas through containers, what test protocols would you recommend for testing?
Your ASTM 4169 does have specific spectra in there as far as the different modes of transportation. And correct me if I'm wrong, Greg, I'm not aware that ISTA has got ocean-going vibration spectra right now.
Actually, me being old here for a minute, I think will help out. There was a presentation done at an ISTA conference, I think back in 2004 by Xerox, that they did a study of both land and sea shipments and found that the most severe shipment was on land, that the sea was very benign. It had consistent temperatures and very low vibration levels, and that there was more potential for damage for the shipment. I can't remember exactly which, I think it was 2004, the ISTA conference in 2004 was presented. But as far as ASTM D4169 goes, it's probably a DC3 because you can do, or sorry, a DC4 because it has mechanical handling in it, or you can do a DC2 and develop your own system for that.
Yeah, that sounds good, and I appreciate your memory there. And I don't just quickly thumbing through 4169. I actually do not see anything in there for ocean-going shipment, and that's probably why, because it's like you say, if it was found to be a fairly benign vibration system, then let's go ahead and throw something at it that will challenge it. Okay.
Okay. Next question. This is a fun one. I get this one all the time, so we'll see. How does ASTM D4169 3 hours of random vibration compare to real world of truck mileage, or does it even?
This question does come up quite a bit, and again, I'll take a stab at it, and feel free to chip in if you want, Greg. The old chestnut that I'd heard for many years was 3 hours of vibration is going to give you about 1,500 miles. Now, I know that that's not completely accurate, and it's going to depend on the roads that you're traveling and the routes and things like that. But that's the old guidance from back a few years ago. Do we have anything more up to date than that, or are we still kind of going with that?
It's not really the hours of vibration. You can't really equate it to miles because of what you said of the conditions of the roads are it's impossible to tell. So it's the likelihood, if you look at the front of the ASTM standard, it's the likelihood that your product will survive. It's more severe the higher level vibrations, so you're more likely to survive more distribution environments. The only one that I know of that equates miles to vibration is the ISTA 3E standard, has a formula in it to equate their duration of vibration to miles. And I think it's 4 hours equates to 1,500 miles is the maximum vibration they have in that standard. Now I'm trying to remember that off the top of my head, so Trace is flipping through the 3 book right now to check and see if I'm remembering correctly.
You're right there. You're right there, Greg. Their maximum test time is 240 minutes, and so divide the test time duration in minutes by 5. And so whatever, I can't do that in my head right now, but 240 divided by 5 would be the what ISTA considers to be truck mileage, because that is a steel spring truck vibration.
Cool, great. Next question, can you correlate ECT to burst? Also, what top loads can a standard C-flute 200 pound burst strength withstand?
Well, that's, again, a good question and has been a bit of a point of confusion with some folks, because you really, when you're measuring ECT, you're measuring a sheet of corrugate in a certain direction, top to bottom. When you're doing the burst testing, you're basically measuring the strength of that board through the side, and so you're measuring two different things. Basically, the higher the burst value or the higher the ECT, the stronger the box. We really can't make a lot more of a side-to-side with that, because you're measuring two different things. And you can get a box that doesn't score well with edge crush that scores pretty doggone well with burst, and vice versa. And so that would be the relationship between ECT and burst. And again, the statement in the webinar regarding the 200-pound burst single wall boxes, this is based solely on what I see and what I've seen for the last several years running tests, is that 200-pound boxes do not do well when you're putting them on their side or on their end, because you're violating the direction that the flutes go in that corrugated container. And the strength of a corrugated container is with the flutes, top to bottom. The flutes need to be running perpendicular with the load, in parallel with the load, And if they're not, then you're going to see some issues. And we've noticed that especially with the 200-pound and lighter boxes.
Great. Thanks, Trace. We're running a little short on time, and I want to respect everybody's time today and appreciate them coming out. So we're going to kind of wrap things up here, and Trace will follow up with all the people that we didn't get back to. If you missed anything or would like to listen to the webinar again, please go to WESTPAK's website at www.westpak.com under the Resources Webinar tab. The webinar materials should be uploaded tomorrow. We highly value your opinion regarding today's webinar, and please expect to receive a short survey within the next hour or so. We hope you'll take time to fill it out, and we use this to determine what our next webinars will be and try and improve the webinars. Our next webinar is entitled The Shocking Truth About the Frequency Domain. It is scheduled for Wednesday, September 20th, and our presenter will be Herbert Schuneman, our founder and chairman of the board. Thank you for attending. I'm Greg Swinghammer. Make it a great day.